Hello, I'm Hyojin Kim in Yonsei University. My advisor is Professor Chang Lee. The topic of my presentation is about reconstruction of super-resolution turbulence through unsupervised deep learning. To accurately analyze turbulence with multi-scale nature, high resolution of turbulence is required. In both experiments and CFD, it is almost impossible to measure all spatial information. In order to solve this problem, recently studies are underway to reconstruct high-resolution data from low-resolution through AI. These studies could be used in ARIES modeling, experimental data, and numerical prediction models. As shown in the figure, turbulence data is unpaired due to chaotic nature. Representative examples of turbulence include ARIES and DNS, or experimental data and simulation data. To provide a general model that can be used for turbulence, we applied unsupervised learning model for super-resolution reconstruction of turbulence. In this study, we considered super-resolution reconstruction in turbulence channel flow. Low-resolution data was applied to partially measured data and areas. The training model was used simultaneously for all velocity components near the wall. The model was again based on supervised learning model. There are two networks, generator G and discriminator D. Through competitive learning of two networks, we obtain a good generator G that reconstructs DNS quality flow field from low-resolution data. We consider the experimental situation in the super-resolution turbulence. Low-resolution data were extracted from high-resolution DNS data from pointwise measurement as sparse grid. Resolution ratio between low and high-resolution data is 8. We assessed whether cycle gun can perform well at a higher friction Reynolds number. We used test data 5 times higher than the trained Reynolds number. Our model shows an impressive extrapolation capability even at a very high Reynolds number. Energy spectra of our model is statistically consistent with that of DNS. This result strongly implies that universality of the relation between the low and high resolution field in wall-bounded turbulence. We investigate the performance of a cycle gun in a test against different kinds of input areas data. As shown in the figure, the reconstructed flow field is similar to DNS despite the data that was not used for the training. This suggests that the unsupervised learning model is not sensitive to input data, and a more practical application will be possible. Thank you for your attention.